First of all, welcome to the final spring 2026 semester edition of the CR2C2 seminar series. Everybody still joining in. Good to get everybody together one last time before we have the long Memorial Day weekend and move into the summer sessions. I'm currently in the process of lining up some interesting outside speakers, so stay tuned. We'll have one or two interesting seminars this summer. I'm put some final touches on those. But today we have two great speakers talking about some of the work that's being done here at CR2C2. The first is Dr. Evangelos Kaiser from Florida Atlantic University, and he directs the Freight Mobility Research Institute there. Very, very apropos, he's speaking on some freight-related issues and research being done by CR2C2. And then the second speaker is Dr. Abai Lidby, one of our very own folks here at University of Alabama, talking about some of the rural transit-related research that we're doing that's to directly engage with some stakeholders here in our region. With that, Evangelos, I will turn it over to you, my friend. You're muted, sir.
Thank you, Stephen, for the introduction. I'm ready to go.
I think you're good. We can see the screen.
Can you see the screen?
Yes.
Okay. So, hello from me, Evangelos Kaiser from Florida Atlantic University in Southeast Florida, Boca Raton area. I'm very excited that gave me this opportunity to be part of this excellent CR2C2 webinars. And I remember that we have been working 3-4 years ago to put this proposal together. It was the same time, in the spring. Anyway, so MRI3 is one of the three areas of this UTC that today I'm going to talk to you about one of the projects that we have completed, the optimal and safe route of freight transportation in rural areas, okay, that this project was a multi-institutional collaboration involving faculty, researchers, and graduate students from 3 universities: Florida Atlantic University, that was leading, North Carolina, A&T, and the University of Kentucky. The co-PI from North Carolina was Ventus Pendley, and from University of Kentucky was Dr. Mei Chen. Also, we have a great number of students that the leading graduate student for this project was Ms. Soheila Saidi from the Florida Atlantic University. So the presentation covers the background, the motivation, followed by methods and case studies. We are going to focus on 3 case studies in this webinar, and I will conduct with the project outcomes, technology transfer, and key takeaways that we have from this project. Before we will start, I would like to give also credits to stakeholders that are working with us, and also they participate in brown back table, and also we presented to them during these 2 years of this work. Rural areas, as we know, has unique mobility and freight challenges due to the long distances, limited infrastructure, and low redundancy. These particular projects focus on how to make the routes more safer and more efficient based on the critical corridors. What is we have the truck parking on rural areas, and also what is the freight resilience that we have in these areas. The main objective of this work is to develop and apply data-driven tools for rural and freight planning that the stakeholders they can use it. And this is the reason that we had meetings not only with Florida, Kentucky, North Carolina DOT, also we had various meetings with South Carolina, Louisiana, Maryland DOT, and so on. This particular study covers three major states, Florida, Kentucky, North Carolina, and emphasis is on the real world constraints such as crash risk, demand variability, and infrastructure limitations. As we know, nearly 50% of the truck vehicles miles travel in the rural areas, and those also weather-related delays cost 2.2, 3.5 billion annually based on the different type of interstates that we have in rural area and the number of particular roads that are available. In rural areas, we have alternative routes, but are very limited. We have infrastructure issues with the bridges, weight limits for trucks, and so on. Oops, I'm sorry. The other major issue that we have in the United States is the truck parking. We have parking challenges in many states. It's urban, suburban, and rural areas. We are focusing here how we can improve, this situation if it's possible. There is a national shortage of truck parking, especially in rural areas, that about 66% of truck parking facilities are located in rural regions. In states like Kentucky, limited supply forces drivers to park on ramps and shoulders. Similar situation we have in Florida, that we don't have enough parking facilities, and when we have weather conditions that requires immediate attention, we have issues because we don't have a place to park the trucks that usually they are coming to Florida with the supplies. There also we have other states that they have contacted us, regarding our projects to help them with the truck parking and how to optimize the number of facilities. And also we work, with the critical corridors, freight critical corridors, to find out, yes, it has been developed by the different states, by the federal highway, but most of the freight network in different states pass through non-urban areas. And also we would like to find out how efficient were these critical corridors, to be able to make it more, the freight transportation more efficient. Freight volumes are projected to increase by 53% by 2050, increasing stress on rural corridors, especially some corridors that they don't maintain properly every 3 to 5 years. So for this one, we use Kentucky, and we got a very good help from the Kentucky DOT. So the goal here was to identify the high tonnage for rural freight corridors. The project started with a literature review. I'm not going to stay here. Okay, we have done extended literature review to find out what has been published from academic point of view and also from the DOT point of view. And the major goals for this project, MRI 3, were to develop a multi-objective routing models that balance efficiency and safety, Improve track parking safety and accessibility based on the specific constraints that every state has. Also assess freight corridor criticality, add realistic routing behavior for normal conditions and weather conditions. So we had various meetings. Okay, we have monthly meetings with the team, and we develop a multi-object. We develop different techniques to be able to accommodate, these problems. One will be optimization modeling, network analysis, and spatial GIS-based analytics. So also we developed 3 complementary case studies that addressing the different freight challenges based on the information that we are getting from our various stakeholders. We validated and calibrated these models using real-world data from the different sources, and also we have been double-checking this, with the various stakeholders. First, I'm going to start it with the Florida case study that we try to find the optimal routes, okay, based on also on last mile concentration. The Florida case focused on inventory routing with deliveries and pickups. So how we are going to improve the same day delivery to the rural areas. This was a big thing we discussed with the Amazon and Walmart down in Florida. This model considered transportation cost, accident risk, route access tolls, inventory dynamics, geometric design of the roads, and so on. The objective here is to reduce the trips, okay, to reduce the empty trips and a safe routing choice. And when we have the issue, we can find the optimal route to overpass the obstacle or bottleneck of a particular location. And here is an example of the methodology of how we are able to implement it as a multi-route network. Each link has a different, I don't know if it's working. Usually the tracks were moving here, the animation, but each link has a different cost based on the observation that we had by specific visit and talk to the local agencies. A routing decision optimized across multiple time periods based on their needs. We use some real world Walmart distribution network in Florida, especially the north. They have many distribution centers for the companies. Also, the class data supports route level risk estimation, and also we have small instances are solved by different softwares that like a Simplex, okay, Simplex platform, and also will be able to bring different algorithms to be able to get, the solution on reasonable time. This was part of the optimization that we develop an NP-hard problem that will be able to solve it using the super powerful computers that we have it in the lab, and also we'll be able to develop the non-dominated sorting genetic algorithm to metaheuristic method to be able to apply for saving computation time, to reduce the computation time. And high quality Pareto optimal solutions will obtain efficiency here. The little bit I'm going to stay a little bit on the congestion experiments. Here is an example of 10 nodes, 10 distribution centers, 10 areas with the 3 vehicles and multiple periods. We develop different scenarios with more nodes, more than 10, 40, 50, and we have a vehicle capacity based on the needs of the particular area that will be studying in Florida. Results show stable and realistic routing behavior that we're happy, and we will talk with the District 1 in North Florida. They will be really interested to, to implement it if it's possible with us. What else? Here is also to prove it to you that transportation costs using with Pareto will be able to minimize it. Shows benefits like 70 to 14% cost risk savings. That something can be reasonable. We can explore more. The outcome suppose more cost-effective and safer environmentally sustainable logistics in rural areas, and that we will be able, to explore more with more nodes, more cars, and so on, as this is an example. And the part of this case study is the part of this case study is the model approved that we can reduce the empty trips, the backhaul integration between depot and the particular rural area. Results demonstrating improved efficiency and safety and sustainability. Now we are moving to another case study that we have discussed a lot at the beginning of the project. Is about the truck parking. Here the team developed a comprehensive solution to the truck parking shortage with the challenges using a combined methodology framework that integrates spatial analysis with mathematical optimization, and we have 4 classified different types of short-haul scenarios. Here, okay, so we will work to here we'll be able to develop the truck parking suitability index, TPSI, okay, that I think the team have talked with the North Carolina DOT, and also we provided some information to Florida DOT as well. The tools that has been used is GIS, okay, GIS. We use the FAB data from the government that is coming out every 5 years and so on. Here is an example of the outcomes for the figure on the left, that for class 2 demand, the most significant reductions occur when the first 200 million of investment with unmet demand decreasing. When on the long haul on the class 4, because we discussed different classes of backhaul, shows a similar pattern, but at a much larger scale, with the demand decreasing from 3,821 trucks to 2,000, approximately 60-something trucks during the peak parking hour across the state under the budget range. Something that we have discussed with the different transportation agencies like TTI, and they were really happy with our work, and especially with their fluidity model is something that was very complimentary. We develop also a dashboard, okay, and a map that can show the facilities that you can scan it here and get the information. If it's possible, you can scan it here and get the information, okay, from the parking analysis dashboard, which parking, has availability in North Carolina. The stakeholders, such as state transportation departments and freight planners, can use this track parking suitability model to prioritize investment and also to help the drivers, okay, when we are on the interstate road to find the right facility. Now we are moving to the third case study. It's about the critical corridors, freight critical corridors that here we try to identify, as Kentucky is one of the major freight movements in the country, with a lot of cargo moved in and out of the state or going through the state. We would like to see how these, existing critical corridors working, either the normal or different weather conditions, can see how resilience will be. So here we develop and we apply an algorithm, the shortest path algorithm, to identify the what is the right portion of the state that we can use. Okay, so up to 3 minimal overlapping shortest path was generated per origin destination pair that we have developed. The freight on this case study was assigned using a logic-based probabilistic model, and also we have to be able to reflect the realistic route choice behavior. The model identified critical tonnage for rural corridor, validated so strong correlation with the FAF data that were provided by the Federal Highway, and shows also their person R is 0.77 in Kentucky, that shows a very good and strong correlation in rural areas. The results support resilience and emergency planning, something that also we study in Florida, similar to the critical corridors, and the Florida DOT was really impressive of our work. We have some limitations. This study doesn't include out-of-state flows for Kentucky case, okay, which could underestimate the importance of many corridors, because we were not able to get the right information. I think the state didn't have this information, and we are looking for future work with expand to neighborhood states and also to the entire United States, that we have done similar work in Florida and Tennessee. And the accomplishments here is we are talking to different public agencies. For instance, Kentucky Emergency Management or logistic firm could assess the impact of our model for the flood reduce scenarios, including closure for particular interstates in the state, and visualize alternative freight routes that minimize costs and maintain flow continuity in rural zones. In conclusion of this work, we were able to, we are engineers, we make assumptions, but we'll be able to study 3 case studies that will be able to improve the efficiency of the freight mobility, freight distribution on specific states. That also actually we had the opportunity to talk with the different states as well. For Florida, Florida case study demonstrates that the multi-objective model with backhauls can improve efficiency and safety 7 to 14%. with North Carolina finding highlight that the data-driven approach can improve accessibility and safety. We distribute, various investments in around the state. And the Kentucky case established a resilience-oriented frame network modeling approach that we would love to talk to other states as well. This work has major technologies transfer and dissemination of results through this example of journal papers. I didn't put everything. Conference papers we presented to the different conferences in national and international, like the one in the Metros organized every 2 years based freight conference in California. Also, we had various meetings with the stakeholders participating in their future freight planning. We provide our information from our work, and also here at the FAU, we present this project. We talked about this project to different students that they were visiting the FAU campus in Boca Raton, different time, of the year. With that, I will open the floor for questions.